The unmanned surface vessel is the maritime equivalent of the loitering munition, a weapon whose strategic value derives not from its individual capability, but from the mathematics of what happens when you deploy dozens of them simultaneously against a defended target. A single fast attack craft can be engaged, tracked, countered. A swarm of 30 unmanned surface vessels, each one a guided explosive platform accelerating toward a hull at maximum speed, each one approaching from a different bearing, each one requiring an individual engagement decision. That is a different problem. That is not a combat scenario that existing naval close-in defense systems were designed to solve comprehensively. The Iranian Revolutionary Guard Corps Navy had studied this problem since the early 2000s with a specific attention of an organization that understood that its conventional naval forces were qualitatively outmatched by the forces it expected to fight, and that the solution to qualitative disadvantage in a constrained maritime environment was not to match quality for quality, but to saturate quantity past the threshold where quality remains decisive. The facility that the target folder described was the operational heart of that program. An underground complex near the Bushehr Naval Coordination Zone, whose function was simultaneously to train the human operators who managed the unmanned vessel swarms, to develop and refine the coordination algorithms that synchronized swarm behavior against defended targets, and to host the communications infrastructure that connected dispersed launch sites across the northern Gulf to a centralized tactical management architecture. Training, development, and command, three functions in one hardened underground space, positioned near the Gulf Coast where the operational environment the training prepared operators for was visible through any surface observation point. The facility's significance extended beyond the training function. The target folder had established, through collection methods that will not be characterized, that the coordination algorithm development work conducted in the facility's research section had produced in the 18 months preceding the targeting decision a tactical management system whose autonomous swarm behavior exceeded what had previously been assessed as Iran's unmanned surface vessel capability. The system could coordinate swarms of up to 40 vessels against a target, assigning individual approach vectors, managing timing to ensure simultaneous arrival within a 7-second window, and adaptively reassigning vessels from initial targets to secondary targets if initial wave vessels were engaged before impact. 40 vessels, 7-second arrival window, adaptive reassignment. The assessment of what this capability represented against the naval defensive systems protecting American and partner nation assets in the Gulf had been described in the threat assessment language that generates urgency in documents reviewed by decision makers. The targeting decision followed the language. The depth of the primary facility chambers was 41 meters, shallower than the Bushehr plutonium facility that had been addressed in a previous mission in the series in a different geological formation. Where the plutonium facility had been in coastal limestone, this facility was in the specific material that coastal reclamation and construction activity in the Bushehr region had deposited over decades of infrastructure development. Compacted engineered fill over natural alluvial deposits, transitioning at approximately 12 meters to the underlying coastal sedimentary formation. Engineered fill is not a geological formation in the conventional sense. It is human-placed material whose density characteristics reflect the compaction methodology, the fill material type, and the construction timeline rather than the natural geological processes that produce consistent, predictable formations. The weapons engineers who worked the fusing solution had addressed this challenge by obtaining, through collection methods involving direct material sampling at accessible locations in the Bushehr coastal zone, a density profile of the fill and alluvial formation sufficient to develop a fuzing algorithm that could recognize the fill to alluvial transition, adjust its depth estimate for the alluvial material's different density, and detonate within the confidence interval at the facility's operational depth. The confidence assessment was 77%, reflecting the engineered fill's inherent variability, and 23% was documented with the specific note that the variability driver was not weapon capability, but geological characterization uncertainty. The planning accepted 77% because the target's operational significance justified the acceptance. The mission required a single B-2 Spirit, carrying two GBU-57 massive ordnance penetrators. The two-weapon requirement reflected the facility's layout. The training and operations section occupied the facility's primary chamber, housing the operator workstations, the training simulation infrastructure, and the communication systems connecting the facility to the operational swarm launch sites distributed across the northern Gulf Coast. The algorithm development and testing section occupied a secondary chamber 44 meters from the primary, accessible through an internal corridor. Both chambers had to be addressed. Leaving the algorithm development section intact would leave the most strategically significant element of the facility's work product: the coordination algorithm itself, the software and testing infrastructure that represented a decade of development, and that could, if the primary chamber was destroyed while the secondary survived, be used to reconstitute the operational coordination capability at a replacement facility within a timeline shorter than rebuilding the primary training infrastructure would require. Software survives physical destruction only if its hardware survives. Both chambers needed weapons. The B-2 lifted off at 11:07 p.m. The routing to the Bushehr coastal zone from the forward operating location required 8 hours and 49 minutes via the Gulf approach, shorter than most missions in the series, but subject to the same tactical constraint that Gulf Coast targets produced. An approach from the south, over the water, against a defense architecture oriented toward the Gulf threat direction. The Bushehr sector's air defense was not the purpose-built, hardened coverage of the nuclear facility that had been addressed in the previous Bushehr mission. It was the defense of a naval coordination zone, oriented toward maritime threats, stronger at low altitudes and shorter ranges, thinner at the high-altitude, long-range geometry that the B-2's employment required. The EW package had been sized against the maritime-oriented architecture with the specific attention that the sector's recent operational history demanded. The Bushehr region had experienced increased air defense activity in the months preceding the mission, driven by the same strategic context that had produced the targeting decision. More active air defense meant more experienced operators and faster response times. The planning had incorporated both. The tanker contact at 2:18 a.m. completed in 15 minutes over the northern Arabian Sea. The pilot accomplished the connection on the second attempt. The first missed by the specific margin that a light crosswind combined with the boom operator's initial azimuth correction produced, a combination that the pilot recognized and addressed before the operator had completed his repositioning call. 11 minutes of fuel transfer and the tanker was gone. The B-2 continued northwest. The EW package activated at 7:29 a.m. local time, 36 minutes before the planned first initial point. The Bushehr sector's defense architecture included a Bavar 373 battery, covering the Gulf approach sector from a position on the coastal ridge north of the Naval Coordination Zone, the primary long-range threat to the mission's approach vector. An HQ-16 battery provided medium-range coverage of the facility's immediate approach sectors. The inner ring consisted of a Tor M1 battery at the facility's surface security perimeter and a Pantsir S1 deployed at the Naval Coordination Zone's primary control point 3 kilometers east of the underground facility. The Growler flight from the carrier group in the Gulf provided suppression against the Bushehr 373 and HQ-16. The land-based EW asset covered the inner ring. The sector's response to the EW activation was faster than the coastal sector pattern that previous Bushehr region operations had established in the planning database. The Bushehr 373 began frequency cycling at 41 seconds, consistent with an elevated readiness posture. The HQ-16 cycled at 53 seconds. Both cycles were followed by the Growler flight within the latencies the pre-mission rehearsals had modeled. The Tor M1 inner ring battery elevated its scan rate within 90 seconds of the activation, not to fire control mode, but to maximum acquisition scan rate, a posture that increased its sweep frequency and reduced the per-sweep detection probability degradation that jamming produced by shortening the interval between sweeps. Faster sweeps in a jammed environment produced less degraded returns per sweep. The Tor M1 operator was not jamming naive. He was applying the countermeasure that operational experience in a frequently jammed sector had developed. The faster Tor M1 sweep rate produced a contact at 7:41 a.m., 18 minutes before the planned initial point, at 21% detection confidence on the approach vector, below threshold. The operator noted it, watched the next sweep, and received a return at the same bearing at 17%. The trend was downward rather than upward, 21 then 17, which the operator's training associated with the jamming artifact, whose apparent contact was regressing toward the noise floor rather than a real contact whose returns would be rising or consistent. He logged both returns and continued his scan without reporting. The downward trend was his reason. The downward trend was the correct analysis. The B-2 was at a slightly different aspect to the Tor M1's beam on the second sweep, producing the lower return that the operator had correctly interpreted as a decreasing artifact. The interpretation was accurate. The downward trend had produced the correct no-report decision from the correct analysis. At 7:47 a.m., 12 minutes before the initial point, the Pantsir S1 at the Naval Coordination Control Point produced a search radar emission on a frequency that the land-based EW assets allocation had not been suppressing at maximum output. The asset's distribution across the inner ring systems had allocated partial suppression to the Pantsir search frequency and maximum suppression to the Tor M1's acquisition frequencies, reflecting the planning's assessment of relative threat priority. The partial suppression left the Pantsir's search radar operating at reduced effectiveness rather than fully degraded. At reduced effectiveness, the Pantsir's third acquisition sweep at 7:47 a.m. and 31 seconds returned a contact at 33% detection confidence. The operator reported it immediately. Unlike the Tor M1 operator's 21 then 17 downward trend, the Pantsir operator was seeing a single return in isolation without the context of a prior higher return against which to assess trend. A single 33% return in a jammed sector under a sector alert warranted reporting. He reported it. The sector controller received the Pantsir's report at 7:47 a.m. and 44 seconds and issued an upgraded sector alert. The upgrade elevated all systems to the engagement authorized posture. The Tor M1 transitioned from maximum acquisition scan to fire control mode at 7:47 a.m. and 51 seconds. 7 seconds after the sector alert upgrade consistent with the transition time the planning had modeled for this unit based on observed operational patterns. The mission commander saw the TOR-M one fire control activation on his passive warning receiver at 7:47 a.m. and 54 seconds, 11 minutes and 6 seconds to the first initial point. He transmitted the maximum suppression code to the land-based EW asset. The asset redirected maximum output to the TOR-M1 fire control frequency. The redirection reached full effectiveness in 6 seconds. During those 6 seconds, the TOR-M1's fire control radar conducted one full sweep and initiated a second partial sweep before the suppression degraded its picture. The first sweep returned nothing above the noise floor. The second partial sweep, 3/4 complete when the suppression reached full effectiveness, returned a contact at 27% on the incomplete sweep data. 27% from an incomplete sweep was logged by the tracking processor as below threshold and unreportable by the operator's standard. The operator nonetheless noted the incomplete sweep return and reported it as advisory information to the sector controller. Incomplete sweep return, 27%, fire control frequency now jammed. The sector controller had a Pantsir 33% search return, a TOR-M1 incomplete sweep, 27% fire control return, and a sector fully under active suppression. He had enough. He transmitted a swarm alert to the unmanned surface vessel, launch sites distributed along the northern Gulf Coast, not a weapon launch order, but a defensive positioning alert that would bring the launch site security teams to alert status and activate the monitoring infrastructure that watched for surface and air threats to the launch platforms. The swarm alert was the sector controller's doctrine-prescribed response to a possible air incursion in the facility's operating area. It was also, from the mission commander's perspective, an observable intelligence indicator whose appearance in the communication traffic told him that the sector controller had elevated his assessment of the incursion probability to the level that activated protective protocols for the very assets the mission was designed to eliminate the support infrastructure for. The mission commander noted the swarm alert in the intelligence feed at 7:49 a.m. and continued toward the initial point. The swarm alert had not activated weapon systems. It had activated monitoring systems at launch sites that were not the mission's target. The mission's target was underground, 41 meters below the coastal construction zone, and the monitoring systems at the launch sites could observe the Gulf surface and the sky, but could not look through compacted fill and alluvial sediment at what was about to happen to the facility beneath them. The first initial point was at 8:03 a.m. The pre-release checks completed in the compressed terminal sequence that the alert environment required, targeting system GPS solution confirmed, fuzing algorithm loaded with the fill to alluvial transition parameters, stores management system verified against both aim points. The first aim point, the training and operations chamber, was the primary release. Bay doors opened. The GBU-57 released from the forward station. The aircraft corrected the departure pitch with the practiced motion that 15 tons of weapon always required and turned onto the heading for the second aim point. Bay doors closed. The weapon's descent through the engineered fill produced the deceleration profile the algorithm had been developed against. The fill material was denser than the median of the characterization data. The compaction had been more thorough in this section than the sampling had captured, producing a deceleration rate at the upper bound of the algorithm's expected range. Denser fill meant slower penetration and a depth estimate that the algorithm revised upward. The weapon was moving through material that was harder than the median assumption. The algorithm adjusted the fill to alluvial transition depth estimate upward by 2 meters. At 14 meters, 2 meters below the revised estimate, The deceleration profile changed in the way that the transition between engineered fill and natural alluvial material produces. A sudden density reduction as the weapon moved from compacted construction material into the softer, water-bearing alluvial sediment that underlaid it. The algorithm registered the transition and shifted to the alluvial density model. At 34 meters, the alluvial material transitioned to the underlying coastal sedimentary formation. The layer the algorithm had characterized as the final material before the target chambers. The algorithm counted the prescribed depth through the sedimentary formation. The fuse threshold was met at 40 meters, 1 meter above the design detonation depth, within the confidence interval that the fill variability had expanded to account for. The detonation inside the training and operations chamber was effective. The operator workstations, the training simulation infrastructure, the communication systems connecting the facility to the swarm launch sites all ceased to function at 8:03 a.m. and 47 seconds. The second weapon released at 8:04 a.m. and 49 seconds, 62 seconds after the first, the interval the geometry of the diverging second pass heading had produced. The algorithm development and testing Chamao aim point was 44 meters from the first, at a depth the target folder had placed at 39 meters, shallower than the primary chamber, reflecting the secondary chamber's position in a section of the facility that had been excavated at a later stage of the construction program when the depth constraint had been relaxed by 2 meters of additional surface infrastructure above it. The second weapon's algorithm ran against the same fill to alluvial to sedimentary sequence as the first, found the same fill density elevation as the first, and adjusted its depth estimate upward by the same 2 meters. The fuse threshold was met at 38 meters, 1 meter above the design depth for the secondary chamber, within the adjusted confidence interval, effective at the median equipment specification for the algorithm development hardware. The coordination algorithm development infrastructure, the server arrays hosting a decade of swarm coordination, software development, the testing frameworks, the simulation environments, the version-controlled code repositories, experienced the overpressure at direct-range geometry. The secondary chamber was eliminated at 8:04 a.m. and 56 seconds. 41 seconds elapsed between the first detonation and the second. 41 seconds during which the seismic monitoring infrastructure at the Bushehr Coastal Monitoring Station registered a 1.9 magnitude event and was still processing the initial event when the 1.7 magnitude second event arrived. The duty seismologist at the monitoring station looked at 2 seismic events, 41 seconds apart, at the same geographic coordinate, at depths of 40 and 38 meters respectively, and immediately filed an anomaly report. 2 events that, close together at the same location, were not natural seismic activity. They were something else, and the something else required immediate notification of the emergency management system. The notification was filed at 8:06 a.m. The facility's internal communication system registered simultaneous contact loss with both chambers at 8:03 a.m. and 47 seconds, the moment of the first detonation. The facility security duty officer attempted contact on primary and backup channels. Silence from both chambers. He activated the emergency protocol at 8:05 a.m. and notified the base security commander. The base security commander, who had been monitoring an active sector alert, a swarm defensive positioning alert, and now a facility contact loss, transmitted his situation report to the IRGC Navy Regional Command at 8:09 a.m. The Regional Command was still processing the situation report when the B-2 was 190 miles into its egress heading. The swarm launch sites distributed along the northern Gulf Coast registered the cessation of their uplink from the facility's communications infrastructure at 8:03 a.m. and 49 seconds, 2 seconds after the first detonation. The uplink cessation was not an alarm. The unmanned surface vessel systems at the launch sites were designed to operate autonomously in the event of uplink loss, a design philosophy inherited from the recognition that a communications architecture could be disrupted in combat conditions, and that weapons dependent on continuous communication were weapons that an adversary could defeat by disrupting the communication rather than engaging the weapons themselves. The autonomous operation mode preserved the launch site's physical capability. It removed the centralized coordination that the algorithm development section had been producing for a decade. Autonomous operation mode without the coordination algorithm was not the tactical system that the threat assessment had described. It was individual vessels without the swarm behavior that made them a saturation threat. Individual vessels without swarm coordination were the fast attack craft problem that existing naval defenses had been solving for 40 years. The capability that had produced the urgency in the threat assessment language was the coordination. The coordination was in the secondary chamber. The secondary chamber was at 38 meters and 41 seconds behind the first. The post-strike tanker rendezvous at 10:23 a.m. completed in 13 minutes. The confirmation code had been transmitted at 8:06 a.m. The planning element that received it cross-referenced the seismic data from the regional monitoring network. 2 events, same coordinate, 41 seconds apart, depths consistent with the 2-weapon employment solution. Both chambers confirmed. The swarm coordination capability that the threat assessment had characterized as exceeding previous assessments of Iranian unmanned surface vessel capability was gone. The launch sites remained. The vessels at the launch sites remained. The capability that had made them a qualitatively different threat no longer had the infrastructure to coordinate them. The numbers that closed the package, 8 hours and 49 minutes of flight time, 2 GBU-57 massive ordnance penetrators employed in a 62-second sequential interval on diverging headings, 1 TOR-M, 1 operator whose downward trending returns of 21 and 17% produced a correct no-report decision from correct analysis. 1 Pantsir, single 33% return in isolation that produced the correct report decision for the opposite reason. No prior context for trend assessment. Sector alert upgrade. 7 seconds to TOR-M 1 fire control activation, 6 seconds to maximum suppression, reaching effectiveness, 1 incomplete sweep at 27% advisory reported. Engineered fill 2 meters denser than median characterization, fusing depth estimate adjusted upward, both detonations within the adjusted confidence intervals at 1 meter above design depth. 0 aircraft lost. Both chambers eliminated. The unmanned surface vessel coordination capability that had been the program's most significant operational development was removed from the threat calculus 62 seconds after the first weapon hit the fill. Autonomous weapons require coordination to be more than the sum of their individual capabilities. A swarm without its coordination algorithm is a collection of capable individual platforms, well-maintained and ready to launch, that cannot synchronize their approach vectors or manage their arrival timing or adapt their targeting when initial wave vessels are engaged. Not a swarm, a collection. The difference between a swarm and a collection is 41 seconds and 2 weapons and the infrastructure that was inside the chambers when they arrived. The Gulf surface is unchanged. What was coordinating what moved across it is not.